Any further delay, I am honored to present to you an international expert in artificial intelligence and robotics, joining us from our next headliner session. Now, it's someone who greeted her campus visitors with a cobot. This is an autonomous robot designed by her and her team at the Carnegie Mellon University in Pittsburgh. Please welcome on stage, from Carnegie Mellon University, Professor Manuela Veloso, also the Managing Director and Head of AI Research for JP Morgan Chase in New York.
Hi. So I'm going to tell you a little bit about robots. Autonomous robots. I've been at Carnegie Mellon for 35 years and worked on AI. And this is a little bit about just bringing to you what is reality so far. So AI, in some sense, can be viewed as been explained, as disintegration of the ability to process data, make decisions, and actuate. So there is this perception, cognition, and action, which happens to be what makes us all so autonomous, is the ability to actually do these three things. I'm going to illustrate this within the context of mobile robots. And these robots, in addition to actually doing these, they coordinate also with each other. And most importantly, also, they service and interact and coexist with humans. And that's going to be part of what I'm going to tell you. So let's look at the robot. So a robot, and believe it or not, I didn't see any robot anywhere. So we are all like with our cell phones, but we come from all the way from the airport through the city, and there is literally no robot anywhere. So we have a long way to go, because AI is not only the cyber world, but it includes also this physical kind of world and being able to have moving creatures around us. So if you actually see this robot, it's a robot that exhibits perception, cognition, and action in its body. So it has sensors like cameras that enable it to perceive the world. It has a computer that enables it to actually reason, observe the data, and be able to make decisions about actions. And it has wheels, which are its actuators. So it moves. It also has speakers, and it also can listen. But this is an example. And that enables the robot, in some sense, to move at CMU. At Carnegie Mellon, they have been moving for several years, moving literally by themselves. This is a little bit of a video clip that we follow the robot, because most of the time these robots, these cobots, move by themselves. So you have to understand that's what's happening here, and I really want you to appreciate this. And I'm going to be a little bit technical, less technical, more technical throughout the talk. But what I'm telling you is like this. There is something here very beautiful, which is this processing of data. And we'll try to understand what type of data does this particular robot processes. And then the fact that it's actually in real time. So the robot cannot stop and say, OK, let me look at the world and decide if I move forward, if I turn right, if I turn left, and then 10 minutes later or a month later, it makes a decision. There is this need to be processing and acting and reasoning within the same time. So that's a very interesting concept from an AI point of view, which is this kind of like online aspect. So just delve with me for a second what's happening inside of this machine. So inside of this AI system, what happens is the following. So let me just stop this for a second. And that's why I have a podium, because I like to stop and move, and the clickers don't let me stop videos. So that's the difficult part. So what happens is like this. The robot, this AI program that is about like 1 million lines of code, C++, Python, all sorts of like different code, has a map. It has some domain knowledge about the environment. The map could have been learned. It could have been like given as a PDF file. It doesn't matter. What matters is that the robot is going to make its decisions, processing its sensing, based on some map. So the map decides, like, wow, how wide these corridors are, how do you turn? And basically, the robot is all the time, in its real-time kind of motion, estimating where it is on the map. And the most important thing of this slide, of this kind of animation, is you noticing these multiple orange circles. These multiple orange circles mean the uncertainty the robot has on its position. It thinks it's over there, a little bit over here, facing that, facing that. So this is important for us to understand that AI comes with this uncertainty attached to the algorithms. You don't have really AI systems that are capable to know it all the time. And they have some uncertainty, in particular this robot, and then it's processing data, which is the sensing. It doesn't matter, it's depth data, it doesn't really matter. What matters is that as you go, as the robot moves, at some point, it is magical in terms of recognizing some wall. And it recognizes the wall at some distance, and it matches the map really well. And therefore, the robot decreases its uncertainty because of the data it sensed. And when it sees the corner, which is like the Eiffel Tower of that particular kind of space, at some distance, the uncertainty dramatically reduces, and the robot makes decisions that are much more confident because it knows exactly where it is. So think about this in general. No autonomous robots, whatever kind of like AI system you are building, virtual assistants, there is this kind of like combination of uncertainty, sensing, decreasing uncertainty. Then you don't hear anybody talking for a while. The uncertainty increases. Then you suddenly hear something or you find more data. The uncertainty decreases. So you see uncertainty going up, sensing going down. Then you don't sense for a while. Then your uncertainty grows. And there is this beautiful kind of cycle of decision-making, estimating, and really sensing. Is that clear? So this is like general. And when you build an AI assistant, you have to accept and embrace the fact that there is this cycle. Data, estimation, and decision-making, and sensing, and input from humans and input from sensors may reduce the uncertainty, and the AI system knows more. So that kind of like a system has been able to move at CMU and other environments for kilometers. And it still moves as we speak. If you come to Carnegie Mellon and happen to want to go somewhere, you can ask these cobots to guide you, and they are able to take you everywhere. So you have to understand something. I'll come to these later. Anyway, so first item of what I was going to tell you is about this autonomy of motion, being this connection of perception, cognition, and action with some uncertainty and sensing in a loop. However, these robots, believe it or not, have a lot of limitations. So, I'm sorry. You know, they cannot press elevator buttons. They don't have like hands. They literally don't understand everything you tell them. From a speech point of view, they are very limited in their knowledge. And this is something that you have to acknowledge. AI systems will be limited one way or another. And so it's very important to introduce a new concept in this AI, which is the machines themselves having the ability to ask for help. And you can say, oh, Manuela, why aren't they connected to the elevator so they would like talk with the elevator, the Internet of Things? Well, they will still have limitations one way or another. Opening that door, that's more difficult, grabbing that object. So let's acknowledge and embrace and live happily with the fact that AI will have limitations. We do have limitations. I have limitations. You all have limitations. I speak many languages. I play squash, but I don't play any basketball, or I don't know other. So we all are limitation creatures. So is AI. But the beautiful thing is that if we let the AI ask for help, and so this is what I call a novel human-AI interaction. And here is how the robot actually takes the elevator. This robot navigates by itself to the elevator, and then when it gets to the elevator, it just says, OK, can you please push the elevator button and tell me which elevator is coming? So it asks for help to push the elevator button. The human very kindly pushes the elevator button. If there is no human there, it sends me email saying, I've been here waiting, and there are no humans that help me. Too bad. And it's done. Enters the elevator by itself, and then continues asking, press the elevator button for where I want to go. And here is a video we took. But it has done these for kilometers. It passes through the elevator, goes to the 9th floor, goes to the 7th floor, and there is no one there to videotape these particular instances. But the fact is that they moved in all the building, in all the environment. And then most importantly, and here is like, you can also talk with this machine. I don't know if there is sound on. Nope. Well, it was supposed to have sound. Richard, there's no sound. OK, well, it says, OK, go to the small size lab. And the robot says, where should I go? And then it says the small size lab.
I do not know that location.
There you go.
Please
And it says, I don't know, thank you, that location. Please give me a room number. And this human very kindly says 7412. OK, now I know everything I'm supposed to be doing. Now, this machine, this robot, next time you say, go to the small size lab, and it's going to offer. Do you mean 7412? Is that correct? Because someone told me that small size lab was 7412. You say it's correct, it's fine. So this robot is learning not from deep learning, not from really enormous amounts of data, but learns from instruction. This robot is capable of, as it is told these things, to accumulate all these things. And the science now is how do we actually save this kind of small size lab, small size log, whatever is the speech recognized, and we save its weight. So the science I'm not giving you, the math is in fact to keep these numbers such that the robot eventually converges to the most trustful information that it's given. But this is like this thing that I believe we have to understand, which is this, in addition to processing large amounts of data, this kind of like continuous learning. It's always learning. It's told something, it acquires, it remembers. I'll give you another example of learning from instruction in a completely different, just as a parenthesis here, in a completely different environment. And this is very beautiful. So we are trying to have a robot, to teach a robot to actually handle food, to feed the disabled, doesn't matter. But look, what happens here is the following. The human is going to demonstrate the trajectory of picking up food from some plate to drop it somewhere. So the human is in this training mode and provides this data, which is very easy to provide. And, oops, I'm going to let it go. Hold just a second. Oops, I'm sorry. And so, now the interesting thing is that the human, when it gives this demonstration, it does not know how costly it is for the joints of the robot to perform that action. The robot computes 25.8 as the cost. And now the robot, based on that demonstration, is trying to learn what's better for the robot. This is very important for us to understand this mismatch between the autonomous robot and the AI system and the human teacher. And then the robot tries different, oh, look at this, it tries something that only costs 0.51 units and tries to test the human. Is this what you mean? And the human says, well, that's not really what I meant, but you know, that trajectory was not satisfactory. And so the robot is able to do, it's a very sophisticated algorithm on these parameters, similar kind of exploration, and it's able to converge to a path that pleases the human and is much less costly than the demonstration. So I'll come back to this later, but it's very important to do this. Now, finally, I want to talk about the last topic and to tell you about this that is very important, which is this problem, which I don't know if you face, but the problem of actually quitting an autonomous machine. So when you actually see this robot move, if we had robots move around, they then disappear from your sight, and they turn, you know, physically, you might not see them anymore. You might not hear them anymore. When they come back, there is this thing about, I want to know what happened. I want to know, what did you do, and why are you giving me this solution? So there is this issue about transparency in autonomy. How do you go about trying to understand why are you late? What are you going to do next? How do you interact with these machines that eventually will be making decisions for you and do autonomous decisions? If you say, like, book me a flight to Paris, I want to go to these museums, I want my hotel to be close by, I want to walk, whatever, and the machine comes with this solution. And you may want to know, why am I staying in this hotel? What happened? So, how can I explain? Autonomy has this concept, or AI has this concept, that you really delegate, and the thing is doing something, and you may want to know why. Why are you telling me I cannot have a credit loan? Why are you telling me I have to take this medicine? Why do I have this disease? Why do I do something? The machine now, at the intelligence level, is not just giving you the shortest path to go from here to your home, but it's giving you cognitive advice. So there is this need to understand that AI needs to be open, transparent, more explainable. So, but the problem, I'm going to put the next slide, get ready. It's not to be read, it's only like, the impact. So what this is like, these are the internals of a robot. When we write code, if we log things, it's all cryptic to humans. So this robot, as it moves, it's recording its location, its point cloud, mean squared error, 2.06 minus to the minus 19. What does this mean? So think about AI in the sense that it's going to be doing all these algorithms which are completely cryptic to us. And so the question from a research point of view is, how are we going to have this machine say anything about what it did? How do we understand these weights of a neural net? So this is a big challenge. And so I tell you, we need to do research, we need to do developments that enable the translation, not of English to French, or a Portuguese to German, or Chinese to Japanese, or Japanese to English. It's not that. It's that we have to understand that with AI, we are creating also a new language. We are creating this AI language problem, whatever is being recorded there, and the challenge now is translating whatever is there to English or to a natural language. And so, unless we do this, we will continue to be developing AI systems that are only in the solving problem perspective and not explaining how you solve the problem perspective. Because we have been 30 years into just solving problems, and we explained when we had rules to reason about, and then we would explain the chaining of many rules. Now, most of our techniques in AI are not rule-based only, and therefore we lack tools, mathematical tools, we lack tools to trace back what these algorithms are doing such that they can talk with people. So an example that we did for our cobot robots was what we call verbalization, in which literally the robot spells out, describes, not the choices it faced, but the experience it had. And whether this looks like Shakespeare, which it doesn't, it's basically, I started from corridor 3201, it's an enumeration, but it's a translation of thousands and thousands and thousands of data points the robot collected to language. And then in this verbalization, we can actually ask the robot to explain its experience at different levels of detail. And you can have things very high level, and you can have things very low level. And trust me, to have a robot that moves around say, I turned left, it's a PhD thesis. And the reason is because look at how the coordinates are changing, such that the robot decides that the algorithm is turning left, because the data is very noisy. So you are going to have data minus 2532, minus 2631, minus 2527. You are going to have all this data about the location on some XY space. That's what the robot reasons about. And at some point, it needs to detect I turned left. And it needs to detect I went by a corridor. And it needs to detect eventually I went by a kitchen because I saw a microwave and a sink or something like this. So what I'm saying is that I don't have other examples to give you a verbalization besides the autonomous robots, but you need to start thinking about when you developed AI, virtual assistants, when you do anything, that the robots not only provide the solution, but they explain why do you tell me something. And that requires you to challenge the coding of your algorithms to record these things and be able to answer questions. So in conclusions, and I finish exactly with 5 minutes for questions, you know, I'm working with you towards this lasting human-AI interaction in which AI doesn't exist without humans and humans don't exist without AI. It's impossible to pursue our lives without AI, given that we have been producing more and more data. Our society produces data on anything. Even when we come in here, we are scanned. Wow, the data, they know exactly when I came in, they know exactly when I got out. Well, I don't have a choice, otherwise they don't let me in. They didn't even ask me, do you want to be scanned? Well, that's it. But that data is now available, and an AI system can use it to eventually improve our events, our lives. So 4 things to remember today, and basically are this concept that this is a complex integration of data, decision-making, and action. So you do have to include, you do want to include the autonomy. There is this symbiosis between humans and AI in which, very importantly, it's not that humans are, supervising the AI. The AI actually asks for help. The AI takes the initiative, and then you learn from instruction, and you are able to save to use later, and you have to do this interpretability, explainability, and transparency. And of course, I have to thank my students. Thank you very much.
Manuela, thank you. Fascinating to hear your presentation. Thank you so much for being with us here today. I'm going to open up the questions to you guys. Raise your hands if you'd like to ask the professor anything here today about what her and her students have been up to at the university. Please raise your hands. If I can't see you, then wave them vigorously at me. Over there. Hi. Just you at the front. Lovely, thank you. And I saw another hand, I think, somewhere. Did I see a second hand? If I did, raise them, keep them raised for me so I can get a microphone to you. Hi.
Hi.
Hi, I'm Vlad. I'm working for European Patent Office. I saw that the robot had the map of the environment. I wanted to ask if the robot had this map beforehand or it was creating the map of the environment by exploration of the environment.
Okay, so this is a good question, but this particular version, what I was telling you, it was not in learning mode of the environment. It actually had either learned it. This particular one is actually just the floor plan of the 9 floors of the building, which is a PDF file which we can translate automatically to a vector-based representation. But we also have research, or DPSVAS has research on you can learn the map. But there is a moment that the map is learned, and we actually learned long-term features, not really the position of chairs and tables. We learned the non-varying part of the environment, and that eventually stabilizes because walls are not, torn down every night. Okay? Thanks a lot.
Thank you. Any other questions here? Please raise your hands for me. Hi, gentleman just there, and you at the back. I'll try and get to you. Can I get a microphone at the front here, please? Thank you. And we'll come to you afterwards. Thanks very much.
Hi, I'm Haran from data scientist from Ecology. I have thanks for the inspiring talk. I find especially fascinating about translate the language back to from the decision making of the robot back to human language.
Yes.
So my question is that maybe I just got confused at the end of the talk, but are you guys trying to translate the decision making process, the reasoning part of the robot, or are you trying to translate the experience that the robot is doing the exploring? And if so, what are the parameters that you're trying to optimize? Basically, how do you define a cost function for the translation?
That's a very good question.
Thanks.
So the very good question. So basically, this was not really explaining the decision-making process of taking this route. It was more explaining what it had done in its autonomous experience. So currently, we actually basically are more explaining what it did by itself. In this particular case, the experience, which is coming through this route and reaching to a particular place, would be what the final solution of coming up with the decision, did you have a loan or not a loan, is to say the path that it followed to come to that conclusion, which is the actual conclusion here. But you're right that I'm not explaining all the possible choices. I could have gone through the kitchen, I could have gone this, the cost of that was this, the cost of this was that. But there is research also at Carnegie Mellon trying to explain more of the process. But you're right, this transparency, this explainability, the translation of the internals to language is in its beginning. You know, it's in its beginning. So I'm not claiming more than what I have. But I need to tell you one thing that you all should remember. What is a big contribution here is that the AI system, the algorithm, is saving, is logging experience everywhere. So it gets images at 60 hertz, which is 60 times per second, and it saves all its estimates. So it has these gigantic logs that then you can do all the AI on the log to know everything that has happened. So the secret to be able to explain is also to record data throughout the process.
Okay, we'll have to leave it there. I hope that answers your question, though. I promised you, so I will let you have very, very briefly, if you can. Thank you.
Okay, I'll answer very fast.
Yeah, that's Vlad from Arni. Thank you very much. I have the question. To make this explanation, you need to collect data, and it looks like a complex task to collect data for the explanation. Not from the robot, but matching the real log data to the explanation.
Sorry, what's the question?
The question, how to collect data to teach the system for explanation.
Okay, lovely. Briefly, if you can.
Yeah,
Thank you.
very brief. It's a challenge still. I did not collect any data for the explanation. I just extracted the explanation from the actual data, okay, to have this concept. But you're right that we need to gather much more explanation data. Thanks a lot, all.
Thank you. I'm sorry I had to cut you off, but you're here tomorrow, Manuela?
I'm here tonight, not
You're
tomorrow.
here tonight?
Yes.
Grab a drink, continue the conversation. Manuela will be here. Professor, thank you. Appreciate you coming here. A round of applause again for Professor. I will take your hand.